Hello, let's continue our Sudoku adventure with Evener by Riffclown. So we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these purple lines in the grid called Renban lines. What we're doing is we're putting a non-repeating consecutive set of digits on the line, but in any order. So 4 consecutive digits could be, for example, 2, 3, 4, 5, right? You just got to keep adding 1, 2, 3, 4, 5. That's a consecutive set of 4 digits. Now, they can be in order, but they don't have to be. So I could go like 3, 5, 4, 2. So order does not matter. We could rearrange these. What matters is when you take them as a whole, they are consecutive. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I notice there's quite a few 4-length Renbans in this grid. And so let's talk about 4-length Renbans, because that's pretty long for a 6x6. So thinking about what's left out is often easier than what's in. And so we know that there's going to be 4 distinct digits on each of these 4-length Renbans, and there's only 6 distinct digits in total, 1 through 6. So we're going to be missing 2 digits. Now, what 2 digits can we miss? Well, if we're not careful, then we'll break the ability to be consecutive. So we have to take them from the end. So for example, we could be missing the 1, 2. Let's just use this row as an example. We could be missing the 1, 2, making this 3, 4, 5, 6. We could also be missing the 1, 6, just take both extremes, and this would be 2, 3, 4, 5. And the only other option is to be missing the 5, 6, making this 1, 2, 3, 4. So those are the ways that that works. So we're missing the 1, 2, 5, or 6, and not like if we're missing the 2, we have to be missing the 1. If we're missing the 5, we have to be missing the 6. So there's a bit more interaction there. But we're either missing 1, 2, 1, 6, or 5, 6. And I'm noticing this 2 here and this 2 here. Let's just do one at a time. This 2 removes a 2 entirely from this 4-length Renban. So this cannot be, this has to be missing the 1 and the 2. Because it's missing the 2, it has to be missing the 1. And so this is 3, 4, 5, 6. And then this is the same. This one sees this Renban sees the 2. So this has to be 3, 4, 5, 6 as well. And these aren't 4, putting a 4 in one of these two. The other thing to talk about is each of these 4-length Renbans needs a 3 and a 4 on it. Because we can only be missing 1, 2, 5, 6. So if this has a 3 and a 4 on it, this cannot be 3. So it's a 5 or a 6 only. Is there more like that? This column needs a 1. And this can't be the 1 because this would be a 2. So we're going to place the 1 in the column here. And then this is actually 3, 5, 6. Is there something seeing it that would prevent it from being a 3? Not that I can tell. Let's see if there's anything easier. I have an idea. But yeah, there's much easier stuff. Okay, so this 1 looks in here, places the 1 here. Actually, let me talk about the thing I was gonna use. We may not even use it, but what I'm gonna do is I'm gonna just highlight in green every cell that's involved in a 4-cell Renban. Now, what can we say about these cells? Well, we know they contain exactly 4 3s and 4 4s, because each of these Renbans needs exactly 1 3 and exactly 1 4, and I've highlighted 4 of these Renbans. So, therefore, there are only 2 3s and 2 4s left in the grid, and I have not touched this box or this box. So, if I highlight these, there's definitely a 3 and a 4 in here. In fact, the 4 is right there. There's definitely a 3 and a 4 in here. And so any cell that is not highlighted cannot be 3 or 4 because we've already used up all 6 of them in the green cells. We've counted 6 already. There's only 6 in the whole grid. So this actually can't be a 3, but let's not use that quite yet because I think we're about to prove it anyway by just placing this 1 here. So that's a 1, and that makes this 2, 3, 4. If that's a 2, 3, 4 triple, that means this can't be 3 and this can't be 3 or 4. Okay, if this is 5, 6, this is from 4, 5, 6, but it can't be 4. It just has to be consecutive with it, right? So this is also 5, 6. So this is a 5, 6 pair, and that's going to remove 5, 6 from this cell here. Oh, that's actually really interesting. Remember that these 2 cells here have to be whatever's missing from this Renban. There were only 3 combinations of digits we could miss. We could miss 1, 2. We know that we're not doing that because this is a 5 or 6. We could be missing 1, 6. That is possible if this was a 1 and that's a 6. Or we could be missing 5, 6, But this can't be 5 or 6, right? If it was a 5, we can't put a 5 on this red band. If it's a 6, we can't put a 6 on this red band. This is a 5-6 pair, and it sees this cell. So this cannot be 5 or 6. So it must be the 1, and this has to be the 6. And then that defines this as 2, 3, 4, 5. That makes this 5 and 6. That makes this a 3. And this is a 4 or 5 pair. Nice. We got a 3 in the corner. Deep duty. That's a 6. It removes 6 from the whole red band. Placing 6 in the box here. I feel like we're wrapping up. This 4 or 5 pair says that's not 4. This is 2, 3. This is 3, 5. See, I haven't thought about this. I haven't thought about this. This is a pair. Let's think about that. This is 1, 6. So this is an extreme red band. It's either 6, 5, 4 or 1, 2, 3. Oh, it can't be 1, 2, 3. This 2 C's here. This 2 C's here. So this can't have a 1 on it. So this is 6 with a 4 or 5 pair. That's a 1. What else haven't I looked at? I mean, this row just takes care of this red band. It's not gonna. The red band does nothing now that we finished the row. Otherwise, oh, this is just a 1 for this row. That places this 1. Okay, we're done with 1s. What do we need to do to finish 6s? We just need to place the last 1. Okay, so that's our 6. Okay, we finished 1s and 6s. This is 2, 3. Oh, and it's finished, right? This 2, this. Where's the 3? Oh, it's here. That's 2, that's 3. That places 3 on this red band. We get the 2. We get the 3, 4, and 2 here. We get the 5 and 4. We get the 4 and 5. That's 5. That's 4. That's 3. This is a 5. 4 here, and we need 2, 3, 5. So this is 5. This is 3. This is 2. Oh, and I finished in 5:55. Nice. And I was solve count 5. That's fun. Lots of 5s. All right. And 5 is not an evener, I guess. Anyway. Cool puzzle, Riffclown. I liked that. I like the geometry of these 2s, seeing these, and we got to use the properties of them having to have a 3, 4 on them. Lots of good stuff. I really liked how this row worked out. I don't know if that was the only way to work it out, but it was a fun way to work it out, that's for sure. This 5, 6 pair, meaning that this can't be a 5, 6 pair. It really worked out. Cool. Was this a 5, 6 pair the whole time too, or did that work out? Oh, this might have been a 5, 6 pair for the box. I can't believe I used this one instead of this one. I'd have to go back and look at the footage, but that's pretty funny. It's a very Ranks thing to do, though. All right, cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.